Oh, good morning, ladies and gentlemen. It's raining. We are getting some definite rain today. Yep. Oh, wow. Okay, yeah. So, earlier today it was pissing down rain, but it has cleared up and it has become sunshiny, so. Oh. I'm going to talk about the formation of the universe. Okay. So, approximately 13 and a half to 14 billion years ago. That's billion with a B. 13 and a half to 14 billion years ago. And yes, the exact number is pretty much known to within about a million years. Pardon me. Yeah. The universe formed. That is, it expanded from a singularity, which was a compressed and condensed state of energy, consolidated into a spot that was probably about as big as that spot right there. And you can't even see that, that's how small it is. But that was the sum total volume of the universe, approximately 13.75 billion years ago, plus or minus a million. Plus or minus a million. Yeah, that was the size. Pretty small, actually, when you think about it. And this point, this singularity, it had infinite gravity, but it also had infinite pressure. And when I say infinite, what I mean is beyond anything we can measure. So, for all intents and purposes, yes, infinite. Infinite gravity and infinite pressure. And infinite heat, which made the pressure more and more and more. And at some point, this singularity became unstable and it collapsed outward. Pressure and heat overcame gravity. And at relativistic speeds, this tiny point, this micro universe, expanded. It expanded to fill a non volume, a non space, a void. And over the next million years or so, it cooled to the point where photons could exist, where quarks and leptons could exist, where all kinds of subatomic particles could finally exist. And then it cooled some more to the point where electrons, protons, and neutrons could exist. And then it cooled to the point where an electron and a neutron and a proton could get together and form an atom. And this led to the formation of enormous amounts of hydrogen, the most basic element out there. And this hydrogen was unevenly distributed throughout the still expanding universe. And as a result, certain clouds of hydrogen became dense enough that they could exert gravitational attraction on all the other hydrogen atoms surrounding them, which led to the collapse of many clouds of hydrogen into protostars, which then, thanks to atomic fusion became stars. And stars are the factories in which more complex atoms are formed. First, fusing hydrogen to create helium, and then fusing to create even more complex atoms. Lithium, carbon, oxygen, stuff like that. And then finally, at the end of the star's life, it would explode. And there were several stars. There were several billion stars that had formed this way, all exploding within a period of just a few million years, and just a few million years after they had formed. And these explosions caused the fusion of heavier elements, giving us things like iron, copper, gold, zinc, uranium, stuff like that. And that was the beginning and the end of the first generation stars, the population 3 stars, which gave us the elements that allowed the formation of the population 2 stars, which are the second generation. And yes, they organized this in a very bizarre manner. The first generations are population 3. I know, it's ridiculous, but astronomers, they drink some real interesting shit. Believe me. So, astronomers came up with the idea of the first stars being population 3. That is the first generation of stars. So the second generation of stars would be population 2. Now there are some population 3 stars from the first generation. Red dwarfs from that period still exist. They are the longest lived stars. They last for trillions of years. But population 2, the second generation, had stars that were in between supergiants and red dwarfs. Stars like, similar to our sun, G-class stars. Although our sun is not a population 2 star. Population 2 stars existed in a universe that had heavier elements. They were able to have planetary disks, planets surrounding these stars. And when the population 2 stars got old and died, those that went supernova created even more heavy elements. For me, wow. Yeah. This brings us to our solar system, our star, the sun, or Sol, which is a population 1 star. That is the 3rd generation. Or it might even be 4th generation. There's a bit of a debate on that. Is it 3rd generation or 4th? In any case, it's categorized as population 1. See, I told you astronomers were fucked up people. Absolutely fucked up. Bunch of drunks, I'm telling you. Yeah. Anyways. Our star, the sun, is population 1. It's 3rd or 4th generation, and as a result of it being population 1, its planetary disk was absolutely brimming with heavy elements, which allowed it to give us multiple rocky worlds. Mercury, Venus, Earth, Mars, and whatever that thing was that has become the asteroid belt. To say nothing of all the other planetesimals that were either absorbed by other planets or flung out of the system by Jupiter. Yeah. The Earth, thanks to having a moon was able to develop a geologically active core which generates an electromagnetic field that repels the solar wind and keeps the worst solar radiation out, which is why life is able to exist. And why we're able to have an atmosphere and a hydrosphere, and yes, a biosphere. It's that electromagnetic electromagnetic field that keeps out the radiation, and the electromagnetic field is generated by our metallic core being tugged by the moon as the moon orbits the Earth. That's what gives the dynamo effect that makes this planet habitable. And if you're a space hippie or an astronomy hippie, please, if I've made any mistake, correct me, because I welcome correction. I do. But, yeah. The Earth is 4.5 billion years old. 4.5 billion years old. The Sun is probably about 4.6 billion years old. So, yeah. About 100 million years older. It's not much of a difference, but it's a bit of a difference. Yeah. The Sun is older than the Earth. The Earth is shaped out of the debris left over from the formation of the Sun. And as I explained it, the Earth is habitable because it's within the Goldilocks zone, and it has a functioning electromagnetic field that is supported by our moon. Yeah. So, of course, having established a planet with an atmosphere, a hydrosphere, and a magnetosphere, we end up with life, and then we move on to the subject of the next video, which is evolution. But in the meantime, I just want to remind you that the Big Bang is not part of the theory of evolution. And evolution is not part of the Big Bang either. These are totally separate and discrete entities that are completely unrelated to one another. Thank you. And with that, happy viewing.